Hey guys, welcome back to my channel. So all of you have been requesting to put up the GCSE Edexcel Maths paper for November 2025, but unfortunately I can't put the latest papers right now because a lot of people have been targeting my channel for putting up the papers before the mocks and then blaming me for students looking at the papers before the mocks and then being well prepared. Honestly, I don't think there's anything wrong with that, like if the students are preparing for the exam. But since they're targeting my channel and they're trying to bring it down, so what I'm going to do is I'm going to give you a mock paper which is going to be similar to that one, but it's not going to be exactly the same. And with the help of this mock paper, you will have better preparation for your exam. So the latest paper, I'll be uploading that soon, but not right now, not before the mocks, so that no one can blame me that you guys are cheating because of me. So with the help of this document, you will come across several questions that came in the November paper. The values will be different, some things will be different, but it will be good practice for you. So let's start with paper one first. This is non-calculator. So it says expand and simplify. So this is basic single bracket expansion. What you do is you multiply the term outside the bracket with the terms inside the bracket. So just going to multiply -3 with x, then -3 with 6, +5 with 7, and then +5 with -x. Once again, simple single bracket expansion. -3 times x is -3x. -3 times 6 is -18. 5 times 7 is 35. And 5 times -x is -5x. Once you've expanded the bracket, next thing you do is collect the like terms. So for the like terms, the variables are like terms and the constants are like terms. So -3x minus 5x is -8x. And -18 plus 35 is going to be -17. So that's your expanded and simplified answer. Then factorize fully. For the factorization, you see whether there's the highest common factor common between the given terms. We can see that 3y is common. So when you take 3y common, you're left with 2y minus 5 in the bracket. Since we can't further factorize this is your fully factorized answer. Remember to take the number and the variable common, not just one thing. Because if you only take one thing common, it's not fully factorized. Then write in the value of 3 to the power of 0. Anything to the power of 0 always has a value of 1. Whether it's a variable, whether it's a fraction, a number, a positive number, a negative number, anything. If it's raised to the power of 0, it is equal to 1. Then it says Liam cycled 42 kilometers in 2 hours and 15 minutes. Work out Liam's average speed, giving your answer in kilometers per hour. So average speed is basically distance divided by time. So distance is 42. And it's 2 hours 15 minutes. So let's convert the 15 minutes into hours first. 1 hour is 60 minutes. 1 minute is going to be 1/60th of an hour. So 15 out of 60, which is going to be 5, 20, and 1/4. So it's 2 whole number 1/4. So let's rewrite this as 42 divided by 2 whole number 1/4. 2 whole number 1/4 in improper fraction is going to be 9 out of 4. We multiply the denominator with the whole number and add the result to the numerator. We take the reciprocal of the fraction, change the division into times, so it's 4/9. So 42 times 4 is 168. So 168 divided by 9. So to convert this into decimals, we divide 168 by 9. 9 ones are 9. 7. 8 comes down. So 9 times 8 is going to be 72. 6.0. So 9 times 6 is 54. We get a 6, again add a 0, so it's going to keep on giving us 6 recurring. It's going to be 18.6 recurring kilometers per hour. So that's how you find the average speed. And the scatter graph shows the stopping distances for some cyclists traveling at different speeds. We have to describe the type of coordination the scatter graph shows. So you can see as the speed is increasing, so is the stopping distance. So when both things are increasing, it means it's positive correlation. If one thing is increasing and the other is decreasing, that's negative correlation. And if the points are all scattered over the grid, that's no correlation. Then another cyclist is traveling at a speed of 50 miles per hour. Estimate the stopping distance for the cyclist. So for that, we have to first draw the line of best fit. And based on this, I'm getting 53. So that's the stopping distance. Then Sam says it would not be possible to use the scatter graph to estimate the stopping distance of a cyclist traveling at a speed of 10 miles per hour because the estimate would not be reliable. Is Sam correct? You must give reason for your answer. Sam is correct because if we go back to our line of best fit, we can see that 10 is not even a part of the line. Even after extending the line, we can see that 10 is outside the line, which means it's not going to be a reliable estimate. Yes, because 10 miles per hour doesn't fall in the range of the line of best fit. Then A, B, C, and D are 4 containers. Juice is poured into the containers at a constant rate. The sketch graphs below show the depth of container in each container t seconds after the juice starts to be poured. We have to match each graph to the container. So A is going to be graph 3 because we can see that the depth is constant throughout. So A is graph 3. For container B, if we notice, it's wider in the beginning, then it narrows, and then it's again wide. So that's going to be graph number 4. It's increasing first, then constant, and then increasing at a decreasing rate. So that's your 4. Then for C, it's wider first and then narrows down. So that's going to be your graph 1 because it's increasing at a decreasing rate. Because as the graph is progressing, it's going to a constant rate. And lastly, this is going to be 2 because that one shows a very wide, uneven container. So if we look at the second one, it's increasing at a decreasing rate, constant, then increasing at an increasing rate. So that's the second one. The diagram shows a rectangular wall, 14 meters by 3.1 meters. Then a rectangular door is in the wall, which is 3 by 1.2 meters. Alex is going to mix yellow paint and blue paint in the ratio 1:4 to paint the wall. He will not paint the door. Alex assumes that 1 liter of paint will cover 10 meters square. Yellow paint is sold in 1 liter tins, costing 4.35 pounds each, and blue paint is sold in 1 liter tins, costing 5.50 pounds each. Alex has 20 pounds to buy the paint. Does he have enough money to buy all the paint he needs? You must show all your working. Let's first find the area that he's going to paint. Area of wall to be painted. That's going to be area of the wall minus area of the door. So 14 times 3.1 minus 1.2 times 3. So 14 times 3.1 is going to be 3.4 minus 3.6. That gives us 39.8 meters square. That's the area of the wall that's going to be painted. Now they told us that he assumes that 1 liter of paint will cover 10 meters square. Yellow paint is sold in 1 liter tins, which is for this price, and blue paint is this. The ratio of the paint we're going to use is 1:4. So for every 1 yellow paint, we're going to use 4 blue paint. So let's first find how much paint is going to be used. We have 39.8 meters square, which is approximately 40 meters square. So we need 4 liters of paint. So what we can do is now we can find the number of tins we'll be using for yellow and blue paint. So for yellow, it's going to be 1/5 of 40, because 40 meters square is the rounded area that we'll be painting. So that's 8. And then for blue, it's going to be 4/5 of 40, which is going to be 32. So 8 meters square is going to use yellow and 32 meters square is going to use blue. To find the number of tins used to paint the ball, for yellow it's going to be 8 divided by 10, which is 0.8. So that rounds up to 1 tin. And for the number of blue tins, it's going to be 32 divided by 10, which is 3.2. So that rounds up to 4 tins. So obviously we're going to use whole numbers, can't get a partial tin. So total cost is going to be 1 times 4.35 plus 4 times 5.50. That's 4.35 plus 22.00. That's 24.35 pounds. So he had 20 pounds. The cost is 24.35. So does he have enough? No, he does not. Let's do a recap of this. So first we find the area of the wall that is going to be painted, which is area of the wall minus the area of the door. Then using the ratio, we're going to find the area that's going to use the yellow paint and the area that's going to use the blue paint. So 1/5 of 40 gives us 8 meters square, and 4/5 of 40 gives us 32 meters square. Then we find the number of tins that will be needed for blue and yellow. So for yellow, we divide 8, which is the area that's going to use the yellow paint, by the area that 1 liter of tin covers. So 8 over 10, that gives us 0.8. We round that to 1 because we can't get a partial tin, it has to be one whole. Similarly, for blue, we do 32 divided by 10, which gives us 3.2, and we round that to 4 tens. So now for the total cost, 1 times 4.35 plus 4 times 5.50, which is 24.35. That is the total cost of paint that we're getting. Alex just has 20 pounds, so obviously it's not enough for him to buy all the paint he needs. Then Alex's assumption is wrong, and 1 liter of paint will cover more than 10 meters square. How might this affect your answer to part A? You must explain your answer. So if it will cover more than 10 meters square, that means he will need less money. Because the total cost will be less now. That's your answer. The diagram shows two quarter circles with the same center. We have to work out the area and the perimeter of the shaded section, giving your answer in terms of pi. So let's work out the area first. We know this is right angle triangle because it's a quarter circle, so that's 90 degrees. So area of a sector has a formula of theta over 360 times pi r square. So 90 over 360 times pi. For the small sector, that's going to be 4 square. This is R1. This is R2. So that's 1/4 times pi times 4 square. This becomes 1. This gets cancelled out, so it's 4 pi. Now area of the other sector, that's again 90 over 360 times pi times 6 square. That's 1/4 times pi times 36. 36 divided by 4 is 9. So 9 pi. So shaded area is going to be 9 pi minus 4 pi. That's 5 pi centimeter square. Now talking about the perimeter, we need the arc length. So first arc length is going to be 90 over 360 times 2 pi r being 4. So that's again 1/4 times 2 pi times 4. So that's 2 pi. Then for the other arc length, that's going to be 90 over 360 times 2 pi times 6. 1/4 times 12 pi, and that's 3 pi. So this is 2 pi, this is 3 pi. This distance is going to be the difference of 6 and 4, which is 2. So perimeter of the shaded section is going to be 3 pi plus 2 pi plus 2 plus 2. That's going to be 5 pi plus 4 centimeters. That is the perimeter of the shaded section. So remember the formula for the area of sector, which is theta over 360 times pi r square. For the arc length, it's theta over 360 times 2 pi r. For the area, you just subtract the area of the small sector from the large sector. For the perimeter, you have to find the arc length for both the sectors and the other lengths of the shaded part. Then line L is shown on the grid. We have to find an equation for this line in y equals to mx plus c. So we have to use the slope-intercept form. This is your y-intercept. So c is -2. C value is always the y-intercept. M is your slope. So for the slope, what we can do is you can pick 2 points on the line, preferably whole numbers. So if you pick this point and let's say this point over here. So this point is -2 and 4, and this one is 2 and -8. So for the slope, we can either use rise over run or the formula, which is y2 minus y1 over x2 minus x1. y2 is going to be -8, y1 is going to be 4, x2 is going to be 2, and x1 is going to be -2. That's -12 over 4, which gives us -3. So y equals to -3x minus 2. Using rise over run, we can create this triangle. If we start walking from this point, we're going 1, 2, 3, 4 units to the left. So -4. If you're going to the left, it's going to be negative. If you're going to the right, it's going to be positive. 1, 2, 3, 4, 5, 6 units up. But if you look at the scale, it's 2 units between each block. So this is going to be 12 units up. Remember to look at the scale. If you hadn't looked at the scale, you would say that it's 6. And 6 divided by 4 would be 3/2, which would be incorrect. Then Ethan buys 25 rulers for 35 pence each. Ethan sells 15 of the rulers. He sells each ruler for the same price. Ethan makes a 50% profit on the price he paid for all 25 rulers. Work out how much Ethan sells each of the 15 rulers for. Shows you all your working. So first you multiply 25 with 35 to see how much he's paid for the rulers. That equals to 8.75 pounds. So he's making a 50% profit. So 50% of 8.75 is going to be 4.375 pounds. So 8.75 plus 4.375 is the total that he has earned. So we're trying to find how much he sold the 15 rulers for, because they're saying he made a 50% profit. So that means on the cost that he paid, add 50% of that to it to get the amount that he's earned. So cost of one ruler out of the 15 is going to be 3.125 divided by 15. That's going to be $0.875, which is 87.5 pence. So once again, like I told you, I changed the values, and because of that, the calculations look like more big, because like the numbers are weird. The actual test, you will get smaller numbers, which will be easy to calculate without the need of a calculator. But for the steps, you first find how much he's paid for all of the rulers. Find 50% of that, because that is the profit that he's earned. Then you add that to the original amount for the total amount that he's earned. Then you divide that by 15, because we're trying to find the cost of each of the 15 rulers that he has sold. So the total earning divided by 15 gives us the cost of each of the 15 rulers. Then the table below shows information about the ages and years of the children in a school. We have to draw a box plot for this information. So we have the least age, which is 5. So this is least age. We have the range, so we can find the maximum age, which is going to be 22 plus 5, which is 27. Maximum age is 27, so that's going to come over here. Now, median is 20. Upper quartile is 25. We have the interquartile range, so we can find the lower quartile, because interquartile range is upper quartile minus lower quartile. So 25 minus 13, that's 12. And you just connect it using the ruler with straight lines. That's your box, and that is your whisker. So you have your box plot. Then we have a question on vectors. Vector A is 1, -5, and vector C is 13 and -11. Given that 3A minus 2B equals to 4C, you have to find B as a column vector. So very simple, you create your equation. First going to multiply 1, -5 with 3, and 13, -11 with 4. That's 3, -15, and that's going to be 52 and -44. Now we swap the 2B with 52, -44. So it's minus, and 2B comes over here. Now 3 minus 52 and -15 minus -44. In vectors, we subtract row-wise. So 3 minus 52 and -15 minus -44. So that's going to be -49. And then we have 44 minus 15, which is going to be 29. Now we divide these by 2. So that is your column vector for B. Negative 49 divided by 2 is going to be negative 24.5, and 29 divided by 2 is going to be 14.5. So that is your answer. Then the next question says shape A is rotated 90 degrees clockwise about the point -1, -1 to give shape B, where shape B is reflected in the line y equals to -1 to give shape C. We have to describe fully the single transformation that is mapping shape A onto shape C. So first, let's find the position of shape B and C. So -1 is our center of rotation. So if we pick a point on shape A, so we pick this point on shape A, we can see that it's 2 units horizontally and 3 vertically. So now for the 90-degree rotation, it's going to be 3 horizontally and 2 vertically. So 3 horizontally and 2 vertically. So that's going to come over here. That's going to come over here. Then for this one, that's going to come over here because that is 3 horizontally, 3 vertically. So 3 horizontally, 3 vertically. And this one is 3 units away from this, so this. So this is your triangle B. Obviously, you'll draw this using straight lines. I'm drawing this freehand. Now, triangle C is a reflection of triangle B in the line y equals to -1. This is y equals to -1. So if we reflect this, it's going to come over here. 2 units away. So again, 2 units away over here. This point comes over here and then this. So this is your reflection. You need to make sure that the image is equidistant from the line of reflection as is the original image. So this point is 2 units away, so the image will be 2 units away as well. That is 3, so that's going to be 3 and so on. So now if we compare A and C, you can clearly see it's a reflection, and it's reflection in the line y equals to x. Because it's not a rotation, it's not a translation, it's not an enlargement. The only thing that's left is a reflection. So y equals to x is your line of reflection. If for someone who thinks this is a rotation, it can't be a rotation because 90 degrees anti-clockwise will be like this, not like this, and clockwise will be like this. So it's not even rotating properly. So the only thing that's left is a reflection. So this is a reflection the line y equals to x. That is the single transformation that maps triangle A onto C. The next question is on recurring decimals. It says express 0.314 recurring as a fraction. So in these type of questions, what we do is begin with assuming that the recurring decimal equals to x. So 1, 4 is being repeated, not 3, because the dots are on 1 and 4. Next, what you're going to do is you're going to multiply 0.314 with 10. So x also gets multiplied with 10 because x is 0.314 recurring. That's going to be 3.14 recurring now. The reason why we're multiplying x with 10 and the recurring decimal with 10 is because we're trying to create another number which will not have a decimal. So it's like a step-by-step thing. First, you assume that the recurring decimal is x, then you multiply x with 10, 100, or 1000, like depending on like where your decimal is going to come. So now we want to make sure that the another number we make, it has 1, 4 after the decimal, because you want to eliminate the numbers after decimal. So we can say that 1000 times x is going to give us 314 0.14 recurring. So 1/4 is again repeated after decimal. If we had multiplied x with 100, that would be 0.31.414. So the pattern would not be same after the decimal. We have to make sure that the numbers after decimal have the same pattern. So now, next what we do is we subtract 1000x and 10x. That's going to be 314.14 recurring minus 3.14 recurring. When we subtract them, what happens is that this side becomes 990x, and this one does not have a decimal anymore. It's a whole number, which is 311. Everything after decimal is getting eliminated. What's left is the number before the decimal. So now x is going to be 311 divided by 990. And we cannot further simplify it, so it remains as it is. This is your recurring decimal as a fraction. If you're someone who struggles with understanding recurring decimals, I would suggest looking at the video above, because in this video, I've used past paper questions to explain recurring decimals in quite detail. Then your question on combinations. So it says a coffee shop menu has 4 savory breads, 7 coffees, and 5 desserts. We have to work out how many possible combinations of 1 bread, 1 coffee, and 1 dessert there are. So for this type of question, all we need to do is that we can multiply these together. So we have 4 possible options for bread, and we want 1 bread. So out of these 4, we can pick any one. Then out of these 7 coffees, we can pick anyone. Out of these 5 desserts, we can pick anyone. So we just do 4 times 7 times 5. 4 times 5 is 20. 20 times 7 is going to be 140. So we have a total of 140 possible combinations for getting 1 bread, 1 coffee, and 1 dessert. Then it says solve 6x times 2x plus 3 equals to 11x minus 1. So we have to solve this equation and find the value of x. So first step is always to expand the brackets. So 6x times 2x and 6x times 3, which is 12x squared plus 18x equals to 11x minus 1. Correct all of the terms on one side. That's 12x squared plus 7x plus 1. So now to solve this quadratic equation, you can use either the quadratic formula or middle term breakage, whichever is easy for you to understand. I'm going to use middle term breakage. So we multiply the quotients of x squared and the constant. So 12 times 1, that's 12. Now we pick factors of 12. So we have 4 times 3, and we have 6 times 2, along with 12 times 1. We're going to pick that pair of factors, which when added or subtracted gives us the middle term, which is 7. So that's going to be 4 and 3. 12x squared plus 4x plus 3x plus 1 equals to 0. Now we factor by grouping. We split the equation into 2 groups. In the first group, we have 4x common. So 3x plus 1 goes in the bracket. In the second group, we have 1 common. So 3x plus 1 goes in the bracket. So between 4x and 1, we have 3x plus 1 common. So that leaves 4x plus 1 in the bracket. So one value of x is going to be negative 1 over 3. And the other one is going to be negative 1 over 4. These are your values of x. Then it says, here's a triangle PQR. Show that x can be written in the form of a root b, where a and b are integers. So we can see that over here, we have one complete pair of length and angle, which means we can use the sine rule. In order for you to use the sine rule, it needs to be a non-right angle triangle, and the triangle needs to have one complete pair of angle and length. So the length opposite to an angle is the pair for that angle. Similarly, over here, we have the angle, we need to find the length. So we can say that 12 over sine 30 equals to x over sine 45. Now, as you know, this is a non-calculator paper, so we cannot use the calculator to find the value of sine 30 and sine 45. But for this, you need to know your exact value of trig ratios. You need to know new to the value of sine 30, sine 60, sine 45, cos 45, cos 30, cos 60, tan 30, 60, 45, all of these. So either you memorize those or you use the special triangle. So if you use the special triangle for sine 30, we use the 60, 30, 90 ratio. The length opposite to 30 is going to be 1. If the length opposite to 30 is 1, the length opposite to 90 is going to be twice of that, and the length opposite to 60 is going to be root 3. So sine 30 is going to be opposite over hypotenuse. This is your opposite, this is your hypotenuse. That's 1 over 2. That's the value of sine 30. Now for sine 45, we make the 45, 45, 90 ratio. 45, 45, 90. So the lengths opposite to 45 are going to be 1, which means the length opposite to 90 is going to be root 2. So sine 45 is going to be 1 over root 2. You can make either of these the opposite because it's the same angle. So 12 divided by 1 over 2 equals to x divided by 1 over root 2. 12 times 2, because it's 12 divided by 1 over 2, so we take the reciprocal, it becomes 12 times 2. And this becomes x times root 2. So now we have 24 over root 2 equals to x. They want the answer in this format, so we rationalize the denominator. To rationalize the denominator, you're going to times and divide the fraction by the surd in the denominator, which is root 2. That's going to be 24 root 2 over root 2 squared. Square of a surd is the number inside the surd. So 24 root 2 over 2, which simplifies to 12 root 2. So 12 root 2 is the value of x. So for these type of questions, especially for paper 1, you need to know your exact values of trig ratios because you can't use the calculator. So if you don't know the values, you won't be able to solve the question. So best option is just memorize a special triangle. You make the special triangle on your paper, mark the angles, find the ratio that they're talking about, and then use the value of the question. Then solve 3x minus 2 over 3 minus 4x plus 1 over 5 equals to 11x plus 2 over 15. You must show all your working. So solving an algebraic fraction. So whenever you're trying to add or subtract fractions with unlike denominators, first step is to make the denominator same. So for that, we multiply the first fraction by 5 and second fraction by 3. This way, both the fractions will have the same denominator, which is 15. So 5 times 3x minus 2 over 15 minus 3 times 4x plus 1 over 15 equals to 11x plus 2 over 15. 15x minus 10 minus 12x minus 3. Rewrite it as a single fraction. So that's going to be 3x minus 13 over 15. Now we can see that both sides are being divided by 15. So if we times both sides by 15, that gets rid of the denominator. So we're left with 3x minus 13 equals to 11x plus 2. Collect the like terms on each side. Negative 13 minus 2 equals to 11x minus 3x. That's negative 15 equals to 8x. So negative 15 divided by 8 is x. So that is the value of x. Then find the coordinates of the turning point of the graph of y equals to 3x squared plus 7x minus 11. So for this, we have to use completing square method to convert this into completing square form and then identify the coordinates of the turning point. So the first step is to make the coefficient of x squared 1. So for that, we'll take 3 common from the entire equation. It's going to be x squared plus 7 over 3x minus 11 over 3. Like I said, if the quotient of x squared is anything else but 1, we have to make it 1. We have to take that number common from the entire equation. Once we've done that, next step is to realize that this is the square that we want to complete. A complete square is a square plus 2ab plus b square, which is the same as a plus b square. So we have our a square, we have our 2ab, we have to identify our b square. So a square is x squared, which means a is x. 2ab is 7 over 3x. So a is x, so 2xb equals to 7 over 3x. So based on this, our b is going to be 7 over 3 times 1 over 2, which is 7 over 6. So we'll write this as y equals to 3 bracket x squared plus 7 over 3x plus 7 over 6 whole square. Our b value is 7 over 6, so we write b square, so 7 over 6 squared. Now we write minus 7 over 6 whole square as well. Why are we writing minus 7 over 6 whole square? The reason behind that is that when we're adding something new in the equation, we're supposed to subtract it as well. Similarly, when we're adding or subtracting fractions with unlike denominators, we multiply the numerator and denominator by the same number, not just the denominator. So it's the same concept over here. If we're adding something new, you're supposed to subtract it as well. So since 7 over 6 whole square is something new that we're adding in the equation, we subtract 7 over 6 whole square as well. Now we rewrite this as a complete square, which is going to be 3 bracket x plus 7 over 6 whole square. This will be outside the brackets. That's going to be minus 49 over 36 minus 11 over 3. Now we times the 3 with the brackets. So it's going to be 3 bracket x plus 7 over 6 squared minus 49. 3 divided by 36, that's going to be 12 over here minus 11 over here. Now we combine these. That's going to be 49 minus 132 over 12. So negative 49 minus 132 is 181. So this is your x value of the turning point. This is your y value of the turning point. So for this, the x value is going to be negative 7 over 6 and the y value is going to be negative 181 over 12. The reason why the x value is negative 7 over 6 is because your completing square form is y equals to a times x minus h whole square plus k. Originally, it has to be negative in the bracket. If it's not negative, like over here it's positive, so you add a negative sign with x coordinate. If it's negative in the bracket, then you write a positive 7 over x. You don't write a negative 7 over x. So you have to be very careful about that. If the bracket has a positive sign in the middle, then you add a negative sign with the x value. If it's negative in the bracket, you just keep the value as it is. You just write it as a positive number. Then it says in bag A, number of white counters to number of red counters is 7:3. In bag B, there are 9 white counters and 2 red counters. In bag C, there are 11 white counters and 4 red counters. Vessel takes at random a counter from bag A and puts the counter in bag B. He then takes at random a counter from bag B and puts the counter in bag C. We have to find the probability that there is now an even number of white counters in bag C. Let's first find probabilities for white counters and red counters in bag A. Probability of white is going to be 7 out of 10. And probability of red is going to be 3 out of 10. Then for bag B, the probability of white is 9 out of 11. Probability of red is 2 out of 11. Then for C, probability of white is 11 out of 15 and probability of red is 4 out of 15. So he's taking a counter from bag A, putting it in bag B. And then he's taking a counter from bag B and putting it in bag C. Right now, bag C has 11 white counters. We need an even number. So one we can do is that we can pick a red counter from bag A and then a white counter from bag B and put that in C. Then we will have 12 white counters in bag C, an even number. Other possibilities that you can pick a white counter from A and a white counter from B, and even then C would have 12 white counters, again an even number. Probability of white from A and then white from B. So white from A is going to be 7 out of 10. Now that we've taken a white counter from A and put it into bag B, now we're going to have 10 white counters and 12 counters in total. So that's going to be 10 over 12. Other possibilities said red from A, white from B. So red from A is going to be 3 out of 10 and white from B is going to be 9 out of 12. Why 9 out of 12? That's because we took a red counter from bag A and put into bag B. So now total number of counters in bag B are 12 now. In the second try, bag B will always have 12 counters. What changes the number of white counters or red counters depending on what we're picking from bag A. That's going to be 70 out of 120. And this is going to be 27 out of 120. I'm going to add it up. That equals to 97 out of 120. That is your probability that there's now an even number of white counters in bag C. So once again, you find the probabilities of red and white counters for each of the bags. The first case that we're proposing is that we take a white counter from bag A, put it into bag B, then we take a white counter from bag B and put it into bag C. So this way there are 12 counters for white counters in bag C. So that's an even number. So when you take a white counter from bag A, that's 7 out of 10. Now we've put that white counter in bag B. So bag B has a total number of 12 counters now. So the probability now changes to 10 out of 12 for bag B. Then for the second case, we're taking a red counter from bag A, that's 3 out of 10, putting into bag B. So bag B has 12 counters now. So the probability of white counters would be 9 out of 12 now. So once you find these probabilities, we add them up and that gives us 97 over 120. That is your answer. Then it says find the value of x. You must show all your workings. This is a question for indices. So we have 25 to the power of 2x times 125 squared times 625 to the power of 2x minus 3 equals to 1 over 5 to the power of 18. First step is to convert all of them into the prime factor base of 5. So we know 25 is 5 squared, 125 is 5 cubed, and 625 is 5 to the power of 4. So 5 square whole power 2x times 5 cube whole power 2 times 5 to the power of 4 whole power 2x minus 3 equals to 1 over 5 to the power of 18. Whenever there's a power inside the bracket and outside the bracket, we multiply the powers. That's 5 to the power of 4x times 5 to the power of 6 times 5 to the power of 8x minus 12. Now, whenever we have similar bases being multiplied, the base being 5 over here, we add the powers. So we're going to do 5 to the power of 4x plus 6 plus 8x minus 12 equals to 1 over 5 to the power of 18. So that's going to be 5 to the power of 12x minus 6 equals to 1 over 5 to the power of 18. Now we can rewrite the 5 to the power of 18 as 5 to the power of negative 18 and bring it in the numerator. When you change the place of a base, when you move it from the numerator to the denominator or vice versa, the sign of the power changes. So positive 18 now is negative 18 since we brought the 5 in the numerator. Whenever we have similar bases existing alone on both sides of the equal to sign, we can put the powers equal to each other. So 12x minus 6 equals to negative 18. So that's going to be 12x equals to negative 18 plus 6. which is -12. So x is going to be -1. That is your answer. So for these type of questions, always change the base to the same number. Over here, it's going to be 5. When there's a power inside the bracket, outside the bracket, you multiply the powers. When similar bases are being multiplied, you add the powers. When similar bases are being divided, you subtract the powers. And we can bring a base from the numerator to the denominator or vice versa. And when you move the base, the power becomes negative. So these are all of the rules of indices that you need to know to solve such questions. Then it says ABCD is a parallelogram and AEFC is a straight line. Prove that the triangle ABE and triangle CDF are congruent. So if they're congruent, first we need to see that it's a parallelogram, okay? So this angle is alternate to this angle. Because if two lines are parallel, the transversal passing through the two lines gives us alternate angles, and alternate angles are equal. So this angle is equal to this angle. And since in a parallelogram opposite angles are equal, so if this angle is equal to this, and part of the angles are same, so these two angles are also going to be same because again, alternate angles as well. We already have a 90 degree over here, so that clearly means the third angle will also be equal because in a triangle, sum of angles is 180. So 180 minus these angles will give us the same angle. So this clearly shows that triangle ABE is congruent to triangle CDF because they have the same angles. The length of BC is equal to AD because it's a parallelogram. Angle BAE is equal to angle DCF because alternate angles are equal. BEA is equal to DCF equals to 90 degrees, common angle. Since sum of angles in a triangle equals to 180 degrees, the third angle will also be the same. Hence congruent. Both triangles are congruent. That is your proof. Then here's the graph of y equals to g of x. On the grid, draw the graph of y equals to negative g of x. So when it's negative, we're going to flip it in the y-axis y because it's y equals to negative g of x. So y is becoming negative. So when it's y equals to negative g of x, we're going to flip it in the x-axis because every value of y is now going to be opposite. So whatever is positive becomes negative and whatever is negative becomes the positive value. This value is positive 3. Now it's going to be negative 3. This is positive 1 over here. It's going to be this is negative 1 over here, so it's going to be positive 1 over here. This is 1. This is negative 1 over here. And this 2 is going to be negative 2. So now you connect this with straight lines. this is your graph. So this is a graph of y equals to negative g of x. It's reflected in the x-axis. If it was y equals to g of negative x, then you would reflect it in the y-axis because the x values are becoming negative now. So that's how you transform this graph. So sketch of the graph y equals to cos x. Point P shown on the graph has a y coordinate of negative 0.5. And the graph of y equals to cos x is transformed to give the graph y equals to cos of x minus 60 plus 2. The transformation maps point P to point Q. Work out the exact coordinates of point Q. So negative 1 over 2 is equal to cos x. We have to figure out the value of x. So using this special triangle, 30, 60, this is 1, this is 2, and this is root 3. So we have 1 over 2. So if it's 1 over 2 and we talk about cos, then angle is 60 because cos is adjacent over hypotenuse. So our hypotenuse is 2 and adjacent is 1. So x is 60. So now to find the coordinates of Q, it's shifted 60 units to the right. Whenever it's minus, that means we're going towards the right side. So it's 60 to the right and then 2 up because it's plus 2. So y is going to be negative 0.5 plus 2, which is 1.5, and x is going to be 60 plus 60, which is 120. So q is going to be 120 and 1.5. Once again, if you're adding something directly to x, you subtract it from the given value, and if you're subtracting something from x in the bracket, you add it. So x minus something means you're moving towards the right-hand side. X plus something means you're moving towards the left-hand side. And if you're adding something directly to the function, like over here plus 2, then you're moving up. If you're subtracting, you're moving down. If you're someone who struggles with understanding the rules for transformation of graphs, you check out the link above because in this video, I've discussed different questions for transforming graphs. So it says show that a plus root 12 over 5 plus root 3 can be written in the form of a plus root 3 over b, where a and b are integers. So for these type of questions, we always multiply and divide the fraction by the denominator. But what we do is we change the sign in the middle. So it will be 5 minus root 3, not 5 plus root 3. The reason why we're doing this is because we're trying to rationalize the denominator, and that can only be done if we're multiplying it by the denominator but with the opposite sign in the middle. So for the numerators, we just directly multiply 8 plus root 12 times 5 minus root 3. And again, for the denominator, it's going to be 5 plus root 3 times 5 minus root 3. So once you have created the fraction, you multiply horizontally because we cannot simplify it vertically or diagonally. Now for the multiplication part, for the denominator, we're going to use difference of perfect squares. According to difference of perfect squares, a square minus b square, which is 2 squares being subtracted, will equal to a plus b times a minus b. So if we compare this over here, our a is 5 and b is root 3. So we can just rewrite this as 5 square minus root 3 squared. And the numerator, we just directly expand the bracket like we were supposed to. So 8 times 5, then 8 times negative root 3, then root 12 times 5, and then root 12 times root 3, negative root 3. So that's going to be 40 minus 8 root 3. When you're multiplying a number and a surd, we keep the number outside. We don't multiply it with the term inside the surd. Similarly, 5 times root 12. 5 is outside the surd. But for the surds, when you multiply two surds, you can multiply the numbers inside the surd. So it's going to be 36. The negative stays outside, becomes root 36. In the denominator, now we're going to have 25 minus 3 because square of a square root is the number itself. So it becomes 3. So as we can see, they want the equation in terms of root 3. So we need to prime factorize 12 and 36 and convert it into 3. So 12 is 4 times 3. Since 4 is a square number, so square root of 4 gives us 2. So the 4 comes outside as 2, and it becomes 5 times 2, root 3. For 36, 36 is a square number. Square root of 36 is 6, so it turns into 6. And the denominator we have 22. Collect the like terms. 40 minus 6 is 34. And negative 8 root 3 plus 10 root 3 will be further simplified because they're like terms. So it's going to be 34 plus 2 root 3 over 22. Since 34, 2 and 22 come in the 2 times table, so we can further simplify it by dividing each term by 2. So that's going to give us 17 plus root 3 over 11. So A is 17 and B is 11. So that's your final answer. And for someone who struggles with understanding surds, you can check out the link above. In this video, I've shared different questions for rationalizing a surd, expanding brackets, adding surds, subtracting surds, everything about surds. And with that, we're done with this paper. If you have any questions or confusions, please leave a comment below and help me out. If you understood everything, please like and subscribe, share this video with your friends. And once again, this is not the exact GCSE paper 1. This paper contains questions similar to the questions that came. I've changed the values, and this will greatly help you in preparing for your mock exam. I'll be uploading the videos for paper 2 and paper 3 in the coming days as well, so stay tuned for that.